Hello viewers, welcome to Auntie IJ's chemistry class. In this channel, I'll be helping you out with problems in chemistry. Today, we'll be learning another wonderful topic. We are going to look at another topic, still on electronic configuration. The rules guiding the filling of electrons in the orbitals. The rules guiding the filling of electrons in the orbitals. We are going to look at three rules or three principles. We'll look at Pauli's exclusive principle. Pauli's exclusive principle. We're also going to look at Horn's rule of maximum multiplicity. Horn's rule of maximum multiplicity. Horn's rule of maximum multiplicity. We're also going to look at Hubble's principle. These are the three principles we are going to look at that will guide us on how to fill electrons in the orbitals. Now we are going to start with the Pauli's exclusive principle. Pauli's exclusive principle. What does this principle say? What does this principle say? The principle states that no two electrons in the same atom or in an atom. No two electrons in the same atom or in an atom have the same value for all the quantum numbers. For all the quantum numbers. Recall the quantum numbers we talked about in our previous videos. We talked about the principal quantum number that gives shells number 1, 2, 3 and all that. We talked about the azimuthal or subsidiary quantum number that talks about the SPD F orbital. Today we are also going to introduce magnetic quantum number that talks about how the electrons are deflected in the electromagnetic field. And then we have the spin that says that electrons are moving in opposite direction. That means if you have two electrons in the same orbital, they will not be moving in the same direction. The one we have will be moving in upward direction and the other one in the opposite direction, meaning that they have different values. And the spin quantum number gives them the value of -half and +half. In that case, it means that if we have two electrons in the same orbital, which is also in the same shell, when we get to spin quantum number, they will definitely have different values. One will have +half value and the other one will have -half value. Positive half value and -half value. Telling you that no two electrons in an atom or in the same atom will have the same values for all the four quantum numbers. So it's possible for two electrons to have the same value for principal quantum number if they belong to the same shell, and then for subsidiary quantum number if they belong to the same orbital, and for magnetic quantum number if they belong to suborbitals. Where we have suborbitals, we have the p and the d orbitals. P orbital has px, py, and pz. So it's possible for us to see two electrons that are in the same px orbital, but their spin will be in opposite direction. So I will take an example from electrons in p orbital. Say two electron in 2p orbital. Say I have 4 electrons in 2p orbital. So we have 2p4. Recall that p orbital will contain a maximum of 6 electrons. In that case, if we are to draw the electronic diagram, representing the 2p orbital, where we have the 2p orbital, this is 2p orbital, we have px, we have py, we have pz, and then we have 4 electrons to be filled here. We have 1, we have 2, we have 3, and we have 4. Take a look at the 2 electrons in the px. Px contains 2 electrons. Look at the electrons. One is spinning in the upward direction, and the other one is spinning in the other direction. In that case, if we have this to be plus half, this other one that is like this will be half minus half. That is positive half and negative half. That is Pauline's exclusive principle. Now let's go over to Horn's rule of maximum multiplicity. Horn's rule of maximum multiplicity. Horn's rule of maximum multiplicity. Let's look at what the rule is like and how it will guide us in filling electrons in the orbital. I must say at this junction that filling the electrons in the orbital will enable you to know the electrons that are moving and the ones that may come in. Let's look at Horn's rule of maximum multiplicity. Horn's rule of maximum multiplicity states that electrons are filled in the orbitals singly first before pairing. In that case, if you are filling electrons in orbitals, you fill them singly first before you begin to pair, if you have extra electrons to fill in that orbital. I also take this 2p orbital or 3p orbital. P orbitals will illustrate this very well. Say if we have 2p 4, let me keep using it, okay, 2p4. If we have in shell 2 orbital p containing 4 electrons, how do we fill it? You don't fill it like this. Since we have 4 electrons, you cannot say you fill in this way and this way, where we have px, py, pz, and you have leave pz empty. This is wrong. How do you fill it? According to Horn's rule, the orbitals will get electrons 1, 1 before we talk about pairing. So when we have px, we have py, we have pz, how do we fill now? We fill this 1, 2, 3, remaining 1, we come here. This is the correct way of filling this orbital using electronic diagram. Now, we will look at the third principle. The third principle talks about filling electrons or filling orbitals of lower energy before the orbitals of higher energy. I must say that orbitals are not at the same energy level. Orbitals are not at the same energy level. We have the orbitals starting from 1s. The orbitals and shells are not of the same energy level. according to Hubble. Hubble tells us that orbitals and the shells are not of the same at the same energy level. So the principle, Hubble's principle, states that electrons fill or occupy the orbitals of lower energy. They fill orbitals of lower energy before orbitals of higher energy. Now, how do you know orbitals that of lower energy and those that are of higher energy? We arrange them. We have 1s orbital having 1s, that is the first shell. The only orbital it has is at the lowest energy. We arrange it like this: 1s, 2s, 2p, 3s, 3p, 4s, 3d. And if you recall, when we were writing the electronic configuration of the transition elements, we wrote 4s before 3d. And that is because 3d is of higher energy when compared to 4s orbitals. In that case, this is normally seen when you are filling orbitals in transition elements. When you are writing the electronic configuration of transition elements, you must consider this because of the 4s and 3d. And then, how do we do that? In transition elements, say, let's take a look at vanadium. Vanadium has atomic number 23. And if we are to fill, we have 1s2, 2s2, 2p6, moving according to this, 3s2, 3p6. Then we fill the 4s, 4s2, and then we write 3d3. Recall that 3d orbital is in the third shell, and 4s orbital is in the fourth shell. But 4s orbital is of lower energy than 3d orbital. That's why we fill 4s orbital before moving to 3d orbital, according to Hubble's principle that states that electrons fill the orbitals of lower energy before orbitals of higher energy. Next class, we are going to have a wonderful time. Thank you. Thank you for watching. Don't forget to subscribe to this channel so that you get subsequent videos. If you have questions, please drop your questions in the comment section.